We know that we have a chemical reaction, a chemical equation, whenever we have some chemicals to one side of an arrow and other chemicals to the other side. Arrows always point towards the product, the result. So whatever I have on the right side of the arrow, or where the arrow is going to point, is what we call the product. This is the product side. And whatever I have on the tail of the arrow, that's going to be the reactants or the reactant side. Essentially the ingredients. This is where we have the ingredients, and this is where we have the result. Now, each of the ingredients, we call them reactants. Each of the different materials we get as part of the product, we call them products. Let's look at this model of a chemical reaction. So each one of these shapes represents an element. In this case, the white shapes represent hydrogen. This one represents carbon. The red shapes represent oxygen. Now, think of these as Lego blocks. So what happens in a chemical reaction is like you give some kids some Lego structures. For example, here you give a kid 3 structures. 2 red ones connected to each other, you give them a double of those, and 4 whites connected to a black. And tell the kid, okay, you have 5-10 minutes, break these apart and produce new shapes. And that's what you get. So what happens in chemical reactions, whatever holds the shape to each other, that's the bonds. They are pulled apart, they are broken. You need to break all of these bonds before you can make these new shapes. So the bonds are broken and new bonds are formed. Shapes are broken and new shapes are formed. Substances change into new substances. That's what happens in chemical reactions. Now, other things you need to pay attention to when it is written like this. The subscript symbol tells us how many of the element just next to it do we have in that reactant. So for example, 4 here tells us we have 4 hydrogens, the 4 white ones here. 2 here tells us we have 2 oxygens, the red ones here. When we don't have a subscript, we have 1 carbon. 1 carbon. Now, whenever we have a number that's not a subscript, the number preceding the chemical, in this case it is preceding this element of oxygen, this molecule of oxygen. Since it has 2 atoms, it is both an element and a molecule. So the number preceding it is what we call a coefficient, and it tells us how many of these molecules do we have. In this case, we have 2. When we don't have a number, we have just 1. 1 carbon dioxide, but 2 molecules of water. Now, another thing that we need to realize when we look at a chemical reaction like this, look, we started up with 4 red Lego bricks and 4 white Lego bricks and 1 black Lego brick. What do we get as the result? 4 red Lego bricks, 4 white Lego bricks, and 1 black Lego brick. So the atoms that we start up with in a chemical reaction are the same atoms that we find at the result. So the same type of atom, the same number of atoms exist both in the reactant side and the product side. They have to be the same. Because we have the same atoms at both sides, we should have the same mass at both sides. If we take all of the products, not just one, all of the products together and put them on a scale, they are going to have the same mass as all the reactants together when we put them in a scale. All reactants together are going to have the same mass as all the products together. However, so we have the same number of atoms, the same mass. We also have the same energy. We need to have the same energy on the reactant side as what we get at the product side. Sometimes in chemical reaction we add energy here. So we are not going to get much into that here. Now, however, so you notice we start up with the same atoms, we get the same atoms. But the substances we have on the left are different from the substances we have to the right. That's why it is a chemical reaction. Okay, and this is a summary of what we just talked about.